Hello everyone again to my YouTube channel. Today I want to start a new playlist in my YouTube channel. This playlist it will be for pytorch because some people ask me about this framework. Well, I want just share some fundamentals of this framework. So because as we know in the area of machine learning and data science in general, so we need some frameworks. We need to master some frameworks to work with. And one of the famous frameworks we have in this area is pytorch. Well, this tutorial it will be for beginners and for medium levels. Can I extract and get some information in this tutorial? So before that, I will share with you the official website of this framework, pytorch. I mean. So this is official website as we see here. Okay, anyone can check it and see all these things. So here for installation, okay, yes, we can see the operation system we have. We also see all the prerequisites we need to install this framework in our environment. And also we can learn from this website because we have here tutorials as we see, we have documentation, okay, we hear a lot of things. So for audio, for text, for vision, so we can do a lot of things with this. It's a rich, framework. So, but for today, I want to just share some fundamentals a little before, okay? And step by step, we're gonna build in a big picture about this framework. Well, here I work in my cloud environment, my account in Google Colab, okay? So here, so the first thing we will do here always is to import the packages that we want. So in our case, so PyTorch exists in this environment or this cloud environment. But if we want to work with our local environment, we can just install it using this magic command of pip. Okay, if we're working with this code or Jupyter, we can just starting with the question mark pip install the name of application. In our case is Python, and that's how we work. Here, as we see here in my screen, so we importing PyTorch and also we import a numpy here just for purpose of comparison between two applications we have here. So here we see this command here, torch.com coda is available here. We see because each operation we have here inside of any project we're working area of machine learning or deep learning is a it's a vectors and matrices. Okay, for the reason we need something, we need some place to make these operations happen. So in our case, this kind of operation it's happen in CPU or GPU. Okay, for the reason we were writing this command to check if we this GPU or CPU is activated or not. Okay, my case here I don't use it. Okay, but here in Google Colab, of course, if we want to work with it, we cannot just go here in this place. We can, sorry, we can change in this runtime type here. We can see we have CPU, we have CPU here, we have CPU, and we have also this premium service here. Okay, if we kind of paid for this. Well, here I creating a simple array. Okay, it's a list. Okay, as we see here, we have a list inside a list. List in Python is one of the fundamental data structure we have. Anyone interested to know well of this concept, we can go to my YouTube channel and go to my playlist. You see Python playlist, and then you can discover more in this data structure we have here. Well, I create this array here as you see, list instead of list. See the result after running this. So we get this result here. Also, we can apply this function of type to check in the type of data we have here. So in our case, it's a list, as I said before, it's the structure list. So here also we can apply this numpy to create an array or to convert it to array because here is a list as we see. If I want to transform it or make it as an array, we can use just this keyword of alias, sorry, np.array, and inside of this function of array, we can give it the data or this variable I have here in this case is data, okay? And then if I run again, okay, see the result here. And I can do the same job with a different way. Okay. Also, I can use this command here. We have input as array. Have here array, but we have here as array. Okay, and we get the same result in can. Okay. So so if we continue in our here and our code, as we see here, I creating a variable called tr. So we can call it anything we want here. Can just for education purpose. For the reason I writing this short variable. Tr equal to torch dot tensor data. Here what I do is I try to make it as a tensor. Okay. So the tensor is a counter of numbers. Okay. I can give you the pictures after in the next tutorials. I can explain to you more the tensor how it is with images to understand deeply what's happening here because that is the core of all these things here. Tensor. It's an interesting concept here. Okay, so we have torch to tensor data. That means I convert it to the answer. Okay, I convert this data to answer to a tensor. After run it, I go and apply again this function of type. I give it the tensor here. I check. As we see here, we have torch tensor. I mean, the type or the type of this variable here is a tensor. Okay, and if I want to check the type of each element inside of this tensor, I can just write in this tr or tr here tensor dot that type. The type I mean give me the type of each element we have here in this tensor. So in our case, it's integer 64. It can be integer 32 or 64 float. So that's different. So for this reason here, we apply this to checking the type we have here for each element in our tensor. So again, here I want to create a random matrix here using this function of random rand. Okay, as we see, we have num array equal to in p or this alias of numpy dot random dot rand 3 by 4. Okay, three rows and 4 columns here as we see. Three. Well, this is just a random number between 0 and 1. Okay, we have uh, 4 columns and 3 rows. Okay, and again, I want to convert this torch because here, if I check the type is okay. Here I want to convert it to a torch because here is a numpy. Okay, it's a numpy number here, numpy numbers in this array, and I want to convert it to a torch. Why we have numpy and torch? Because the question of complexity is exists always in each time because we will working in some project of images or something like that. At this time, we have a huge number of matrices and operations exist between all these matrices. So it's taking a time. I mean, we want just to increase this complexity for the reasons this kind of tools like pytorch is coming here. Okay, so that's why the velocity of torch is more than numpy. It's more faster than numpy. Well, so if we still continue here, also we can also do the same job with different way. So in this case, or in this syntax, we are just apply this torch dot tensor, and I give uh, the array here, and we convert it to a torch, and we get the same result here. Same number, the same. Have here that type is a torch float before. We get the same results with different syntaxes. Also, so for torch provide for us also this matrices or these arrays of one or distances of one. Okay, this is very important in algebra. We know the importance of these things if we want to convert or do some transpose of um, matrices. So that's we need this kind of things. Okay. Well, we just exist in a torch, so we can creating this matrix or torch or tensor, sorry, of once 4 by 5, okay, 4 rows and 5 columns, as we see here. Also, we have zeros. We can create a matrix or tensor of zeros here. Just we start the zeros and we give the number of dimensions we want here, columns and the rows. Uh, Here, I want just to so generate some random values here using torch. So first, change equal to torch to main. I want the matrix or tensor of 4, 5. Okay, and if I check the type of each element generated here in this first thing, it's a float 22. Okay, and also I want to check the place of operation, where is happen these operations, or where is the place of storing of this first inheritance CPU. Why CPU? Because CPU is make this kind of operation more faster. Okay, because the resource is very important in deep learning or okay. CPU, GPU is very important to make this kind of operation. Here, as we see, we have this type in CPU. I mean, this first thing is existing CPU. Okay. So there is here it's random numbers generated by Dosh here. Random by 4, 5 here, 4 rows and 5 columns. And also we can trace in the numbers that we want. So here, if we see with me here, I trace all the elements, and I want the column 1, 2, 3. So 3 is excluded. Okay, I mean we have just the column 1 and 2. 3 is not included here. So if we go and check here, where is column 1 here? This is all the numbers 0.14. This is here. All the numbers here because first dimension here for this all the values I want here to store it here. I apply all the values, and for here I tracing just the number of columns I want. In my case we want just 2 columns and 1 and 2 because 1, 0, 1, 2, 3, 4. I want just 1 and 2 do it here. Okay. We have also multiplications. Okay, pytorch provide for us multiplication, as you can see screen. To do that, we can just apply this function of mil. We have first thing dot mil. First thing, I mean, I take the same matrices, okay, using this mil function, and this is the result here. We can also use this way to get the same result. First thing times first thing, the same result here. Uh, we have also here this matrix multiplication here. First thing dot mat multiplication, first thing dot transpose of this matrix here, and this is the result. And we know in linear algebra in matrices, operation of matrices, we know if we want to make some operation of matrices, we need to check in the number of rows and the number of columns. Okay. Here we have 3 by 4, 3 by 4. Well, the result is 4 by 4 because we drop the columns of the first matrix, and we drop the row, the number of row of the first matrix, and the number of column of the second matrix. So for this reason, we need to transpose here, and this is the result here. Also, we can do the same operation here of the multiplication of two matrices or two tensors with this other way, or with this new sentence here. We have torch dot mit matrix melt, torch dot matrix melt, and we give for this function of mat, matrix melt or mat melt, this function of mat melt, we give it we give to this function the matrix we want. Okay, so first in the transpose here, and we get the same result in the end. Well, we can do the same things also with this sign here. The first thing here times first thing transpose, and we get the same result here. This broadcasting here, this version of broadcasting. Uh, we can also apply this function of sum here for the elements. And inside of this function of elements, we can specify the axis we want, 0 or 1. Axis 0, I mean the rows, and axis 1 mean the columns. Okay. So in this case, axis equal to 1, that means I want the sum of each column here. For column 0, for column 1, for column 2, and 3. And the result here for each column we have. And also here by default, if we give just first thing dot sum, so by default axis is 0. I mean, I want the sum all the elements exist in this tensor. Okay. And also we have this function of concatenation. If we want to concatenate between two matrices or two tensors, so we can just use this text. Torch dot concats. So we give inside of brackets, between brackets, we have here first 10 and first 10. I mean, I concatenate the same matrix here, and this is the result here. Like this. We get the same result here. Also, we have these things here. We have torch dot non-need word dot functional dot softmax first 10 with dimension 0. This thanks is very important. Softmax, by the way, is one of the famous activation we have in deep learning, and we use it to solving the problems of classification. So in case of multi-classification, at this time we need this kind of activation functions here. Okay, and the formula of this is with this formula. So we see within here we have the syntax. Sum of the probabilities, or the probability for each class divided by total of probabilities. And at this time, sorry, we see uh, the weights of each values we have here and associated to each class. I want really to describe by detail these sort or activation functions. Things we have rule, we have smart, we have tnh, we have law of functions. But in this case, just why I apply this, because when I apply this non-word softmax, I give the tensor for my softmax, and each element here is it will be rescaled, and the output it will be near to 0 or 1. Okay, here by dimension 0. So if we look in here, each row here, row 1, 2, 3, each value here is not near to 1. And when we give in the same syntax, or we write in the same syntax here, and just I change this dimension and I give it 1, not 0. At this time we see the column here, each column here is near for this value of 0. Okay, I will describe by this softmax function because that is very important to handle the problems of classification or multi classification problem. Okay. Also here we can apply this function of size or shape to check in the size of our tensor. Okay, two ways or two methods do the same job. So if we want just to see the shape of our tensor, in this case we have 4 by 5. Okay. Also we can implement the example of images, because So that is very important in deep learning, especially when you have money work or civilian or making money work. See the example of images here. We have torch command, we have team batch, batch side, we have three channel, meaning we have red and red blue, red blue. We have three colors: red, blue, and white. I remember. I don't know remember it well, but we have three channel here, and we have the pixel of these images 128 by 128. This is just the random values here, and this is the result. So the result here this is like the images, okay? Because when we extract information, the information that we can extract from images is like that, okay? We have matrices, numbers, huge numbers, so for this time, we need this kind of tools to help us to making this complex operation. Also here, we can clip. I mean, we can make my tensor between in some interval. So in this case, my first thing here is will be between 0.2 and 0.8. Okay, that's what we see here. Okay, each value here, we check each value here is between 0.2 and 0.8. Okay. So this just is introduction to pytorch. I hope that this will be clear for you. Well, anyone interested to discover more in this area or in this using this framework, you can just go to official websites. There is a lot of examples to do and to discover more what's happened. Okay, happy learning for anyone. See you again. Bye.